Hello learners, I welcome you all to Dr. D.Y. Patil Vidyapit Center for Online Learning, and we are learning statistics and quantitative techniques, and in this session we are learning the unit 9 transportation. So we'll learn more about the transportation. In the previous session we have learned about the linear programming and how to solve the linear programming problems with two variables. Okay, so that technique we are using is the optimization technique. One of the optimization technique, we were finding the optimum solution in LPP, right? So you're interested in knowing the minimum cost or maximum profit. So in this case also, the transportation problem is related to the sources of production is given to you, then the destination points are given to you. Sources of production means, if you see, generally the big organizations, they have their plants at different cities in different regions, right? So what they do when they get the demand from the different points, destinations, so they directly transport from the nearest plant to the demand point, right? So let's say a particular, let's say, bathtub producing company, it is operating in Delhi, Mumbai, and Kolkata. So let's say Hyderabad, Chennai, and Goa, they need bathtub. So now the company knows the production plants, the company know where their product is, they have to transport, like where the requirement is, they have to transport their product. So the cost of transportation, they know, like how much cost they have to bear if they transport from, let's say, Delhi to Goa or Mumbai to Goa. Maybe the Mumbai to Goa, they need less cost. So accordingly, they have to take a decision. So in this problem, transportation problem, they give you the sources of production, they give you the capacity of production, also the destination points and demand at each destination. Okay, so the transportation problem. So let's see, let me write here. 1 second. So basically, the transportation problem we solve by using three methods. We have the northwest corner method, then we have the low cost method, and we have van method. So by using three methods, we find the solution to the problem. Okay, so let me write here what kind of a problem actually it is and how it looks. So we have three methods to solve the problem, and we can find out the solution, but we don't know whether our solution is optimum or not. So if you want to find out the optimum solution, that time there are two ways of finding it, and the one is stepping stone method, and the second one is Modi method. Okay, so you have two methods for finding out the optimum solution, that is stepping stone method and Modi method. And for finding out the solution to the problem, basically you have three ways. That is, the first one is northwest corner rule, the second one is lowest cost method, and the third one is VAM method. Okay, so in this session we are learning just two methods of finding out this initial basic solution, and we are not checking whether the solution is optimum or not. If you want to find out how to do and how to check the optimality, the stepping stone method is already explained in the videos shared on the Swayam. So whatever the recorded video available on the Swayam, in that video, the stepping stone method is already explained. So I'm explaining you just the first two methods, northwest corner rule and the lowest cost method. So let's see first what kind of a problem it is. So you have the destinations and you have the sources. So let's say there are three sources: source 1, source 2, and source 3. Then supply. Supply means how much they can produce. So the source 1, is producing how much, source 2 is producing how much, and source 3 is producing how much quantity. So let's say the supply, source 1 is producing 200 quantities, then source 2 is producing 300 quantities, source 3 is producing 500 quantities of that particular product. Okay, so you have the different destinations. Let's say the destination A, B, and C. Okay, so and the requirement is written here. Okay, so factory capacity, the supply you can say here as, this is basically the factory capacity. Okay, so sources means the factories, they have 3 factories, 1, 2, 3 located at 3 places. And the factory capacity, the first factory capacity is 200, the second factory capacity is 300, the third factory capacity is 500. So they have the destinations A, B, C, like, so the requirement at destination 1 is 200 units. The requirement at destination 2 is 400 units, and here also the 400 units. Also, they give you the transportation cost. So here the cost is written like, let's say 275, then 3, 4, 2, 547. So this is one of the examples. So the example is available in this kind, like they give you the destination, they give you the sources, and you have to allocate the sources to the destination in such a way that they the with the minimum cost you can do the transportation from sources to destination. For other information available is the factory capacity at different sources they give you, and the requirements. So these are the requirements. So these are the requirements at different destinations. So destination A required 200 units of that product, B required 400 units, C required 400 units. Okay, so what this is, what these numbers are. So when they do the transport from source 1 to destination A, they have to pay, let's say, 2 rupees cost per product. Okay, so these are the cost given, costs of transportation per product. So this is how your example will look. All the costs are given in these cells. So how you interpret this? When the organization or company transports from source 2 to destination B, the transportation cost per product is rupees 4. How you interpret this? When the organization transport the product from source 3 to A, the per product transportation cost is 5. Clear with this, how the example will look? So this type of example you will have, and you have to find out the solution to this. So there are 3 methods: the northwest corner method, the lowest cost method, and the third one is the VAM method. So I'm not going in detail. I'm just telling you how to find out the solution to this using northwest corner rule and lowest cost method. Okay, so then once you know the solution, so whatever the solution you have is the visible solution. Okay, so it is a solution to this problem, but you don't know whether it is optimum or not. So at the end, when you solve this example using, let's say, the northwest corner rule, you will come up with some cost, right? So the cost the company will bear. So there is a possibility that there is some another solution which using which you can lower your cost. The whatever the cost you are finding is optimum or not, you have to check using the 2 methods you have, that is stepping stone method and Modi method. So I'm not explaining you how to check the optimality in this case. I'm just explaining you in this session the 2 methods: northwest corner rule and lowest cost method. Okay, so what is given in transportation problem? The destination and the sources are given. Also with the sources, the factory capacity is given, with the destinations, the requirement at different destination is given. So when you learn the transportation problem, basically your objective is to find out the initial basic solution and then check whether your solution is optimum or not. Okay. So this is a special case of linear programming. So with multiple variables you have and multiple equations, the origin points and the capacity of the supply per period at each point you need to know. So you need to know whatever I have already explained you this. You need to know this before starting. You need to know your sources, then supply. You need to know the destinations, the requirement, and the cost of the transportation. Okay, so the interactive procedure that finds the least costly means of moving products from series of sources to series of destinations. So you are using this to find out the solution when you have to do the transport from series of sources. So you have number of sources and you have number of destinations, and you are doing the transportation from sources to destination. So let's come up with the example. The following example was used to demonstrate the formulation of the transportation model. So here some information has been given here, and we can use this information and formulate the actual transportation problem. Bathtubs are produced in plants in three different cities: Ahmedabad, Indore, and Hyderabad. So now you have the three cities where the bathtubs are they're producing the bathtub. Three cities are Ahmedabad, Indore, and Hyderabad. Like Ahmedabad, Indore, and Hyderabad. So what these are the sources of production, right? So you can write here sources for your understanding. Okay, so ultimately you will have some destinations. Okay, so read further. Ahmedabad, bathtubs are produced in the plants of three different cities: Ahmedabad, Indore, and Hyderabad. Tub is shift to the distributors in railroad. Each plant is able to supply the following number of units. So Ahmedabad plant is producing 100 units, right? Ahmedabad plant is producing 100 units. Indore plant is producing 300 units. Hyderabad plant is producing 300 units. Tube will be shipped to the distributors in three cities. Now, these are the destinations. So, which destinations? Mumbai, Kolkata, and Delhi. Okay. So, the distribution requires the following units. So, Mumbai, they need to transport 300 units, Kolkata, 200 units, and Delhi, 200 units. The shipping cost is given 543,843. Let's write it here. $975. Okay, now this problem is in front of you. So how your problem how your problem looks. So how they can do this? Like the three cities are, let's say, Ahmedabad, Indore, and Hyderabad. So from Hyderabad, or let's say from Ahmedabad, they can send their products to all three places where there is a requirement. Like Kolkata, they can transport their products to Delhi or Mumbai. From Indore also they can do it, like from Indore they can transport their products to Mumbai, then to Delhi or to Kolkata. The third factory is at Hyderabad, and they can also transport their products from Hyderabad to Mumbai, to Delhi or Kolkata. So always uh, the transportation is possible. But what we are trying to do is we are trying to solve the problem in such a way that the transportation cost is minimum. So and the transportation will be easy, like if all of they transport a few of their products to all three places, ultimately they end up with the maximum cost. So we try to allocate the destination to the sources with the cost. So this is what our problem is, what we have formed. So again, so you have here Mumbai, Kolkata, and Delhi. These are your, you can say, destinations, and these are the sources of the production. So respective, the capacity of the production is here. The requirement at different destination is here. Uh, so you are transporting from sources to destinations, okay, and the cost of transport is given in each of the cell, 54384, and this cost are the per unit cost of the transportation, okay. So here if you see the total capacity of uh the factory production is 700, and the requirement is also 700. So your you can say the capacity is matching with the requirement, or supply is matching with the demand. So you can say this is your supply, like whatever the factory capacity is your capacity to supply. So you can say this is your supply and this is your demand. So you will always check whether your supply is matching with the demand or not. So if your supply is matching with the demand, that time you can go for the further treatment and you can solve your problem. If your supply is not matching with the demand, that time we have to take some actions, like we have to take a corrective actions. We have to add the dummy row and dummy column accordingly, and we have to solve the problem. So when supply is equal to demand, we say that this is a balanced transportation problem. Okay. As supply is equal to demand, the total of this column is equal to the total of this row. Here it is 700. That's why we are saying that this problem is a balanced transportation problem. Okay. So if you have here 800 and if your demand is less, that time you have to add one more dummy column here to like, let me give you one more example here. Like if you have A, B, C, let's say there are three you have three sources of production, and there is requirement are four destinations. That time you can say this at destination 1 the demand is 50, the destination 2 the demand is 100, destination 3 the demand is 50, and again that is 100, and total production of A is, let's say, 100, B is also producing, let's say, 150, and C is producing 100. So if you do the total available supply is 350 and the total demand is 200, right? So in this case, this demand is not matching with the supply, so you can say that your transportation problem is unbalanced. So what you have to do is you need to add one more dummy. You demand is less, right? So you need to add one more dummy column here. So now you can write like this: A, B, C, D you have here. So we'll come up with one more dummy destination and we allocate the remaining supply to that destination. Okay. So if you have the supply demand is more and supply is less, that time you have to add one more dummy row. Okay, so in this case, what you're doing, you're writing the demand, like here the demand is 50, here the 100, here the 50, here the 100, and the remaining demand, like the total is 350 here, right? So A is producing 100, B is producing 150. Sorry, the A, B, C, D is not there, right? I'm so sorry. So just ignore that this column is there. Let me erase this. So the demand for at destination 1 is 50, destination 2 is 100, destination 3 is 50, destination 4 is 100. So what is the total here? 100, 100, 200, 300. So the total here is 350, right? 100, 150 and 100. So the 50 more we write here 50. The remaining 50 we write here and the cost we write 0, 0. And we'll write the remaining costs from as it is from this example. So if your problem is not balanced at time, first you have to balance your problem and then only you can solve it. So we'll start with the northwest corner rule. So let's see how to solve the problem using the northwest corner rule. So if you have the problem like this, let me write down the problem here. The same problem will solve like Mumbai, Kolkata, and Delhi. Then we have the capacity of the production. That is a supply, right? So we are writing here the sources: Ahmedabad, Indore, and Hyderabad. So at the end, in this, here I'm writing the requirement at Mumbai, Kolkata, and Delhi. Okay, so you're transporting from from Ahmedabad, Indore, or Hyderabad to Mumbai, Kolkata, or Delhi. So let me write down the remaining numbers here. So the cost is 543,843 and 975. The capacity is 100, 300, 300. And the requirement at Mumbai is 300. Kolkata is 200 and Delhi is 200. Now, the first thing you have to do is you need to check whether your supply is matching with your demand or not. So you're adding capacity and requirement and checking whether the two additions are giving you the same total or not. So here the 700 is the total, right? So It is a balanced transportation problem, so you can start solving as it is. So now in northwest corner method, you're starting with the allocation from the northwest corner. So what is the northwest corner here? So this is the northwest corner. So okay, where we are doing the allocation. So we are doing in these within these cells. Okay, let me show you where we are doing it. So within these 9 cells, we have to do the allocation. So we start with the northwest corner. So this is the northwest corner. I'm writing here one bracket. So what we are doing, we are assigning the minimum of these two numbers. Here the 300 and 100. So minimum is 100. So I'm assigning 100 here. So 100. What is 100? 100 is the supply. Right, 100 is the supply available from A. And what is M? Mumbai needs 300 units. Okay, so but A can only fulfill the 100 units out of 300. So what you're doing, you are assigning 100 here, the minimum of 2, and you are saying now this is 0, no more units available for the transportation from Ahmedabad, because they're already transporting all the units to the Mumbai. Okay, so you no more transportation from Ahmedabad, so you are canceling these cells. Okay, so now at the time you have allocated 100 units, so 100 requirement is already fulfilled, so 300 minus 100 is 200 requirement is there for Mumbai now. Okay, so the next northwest corner is this cell, right? So I'm again writing here, making one square and allocating the minimum of these two values. So minimum of 200 and 300. Minimum of 200 and 300. What is minimum? 200. So I'm writing here 200. So now I've allocated the 200 here. Now the Mumbai's requirement is totally fulfilled. So you are canceling this and you are reducing this by now out of this 300, you have already done the supply for the 200 units. So remaining 100 units are there for supply. So the next is this cell. So we are making one square here. Again, we try to allocate the minimum 200 and 100. What is the minimum? 100 is minimum. So remaining 100 we are transporting to the Kolkata. So now no more availability for from Indore. So we are canceling this. Okay, so now you have already allocated 100 here, so this is reduced by 100. So now the next cell is this, so you will allocate 100 here. So you can say here it is 0 and it becomes 200. So for this cell, the next allocation is 200. Okay, so this way you can solve examples using the northwest corner method. So you're starting with the northwest corner in the transportation problem and you're allocating allocating the units, and you end up allocating all the units. Second one is you want to see the last slide, and which slide you want to see? This slide? Here we have allocated the dummy column so that the total is 350. So this is where we do the allocation in northwest corner rule or northwest corner method. Okay. So now what we have done the allocation here. like from Ahmedabad to Mumbai, right? So from Ahmedabad to Mumbai, the first allocation is from Ahmedabad to Mumbai, right? So what is the total cost? 100 into 5. Then the allocation is from Indore to Mumbai. Indore to Mumbai. So what is the cost? 200 into 8. Then the next allocation is Indore to Kolkata. Indore to Kolkata. So what is the allocation cost? Transportation cost? 100 into 4. So the next allocation is from Hyderabad to Kolkata. Hyderabad to Kolkata. 100 into 7. And Hyderabad to Delhi. Hyderabad to Delhi. And the cost is 200 into 5. So if you do the total of this, you can calculate the total cost. We have already calculated it here. The total is 4,200. So this is the feasible solution. Okay, but this is not, you cannot say that this is the lowest cost. You can have the alternative cost because you have not checked the optimality here. For checking the optimality, you have to perform either of the two methods, like a stepping stone method or Modi method. You have to do the calculations using these two methods. Either of the two method, and then only you can confirm that whether this cost is minimum or not. So the second method is lowest cost method. So again, you will have the similar, let's solve the same problem using the lowest cost method. So what you're doing here is, again, I'm writing the same problem. So we have Mumbai, we have Kolkata, we have Delhi. And here we have the production facility at Ahmedabad, Indore, and Hyderabad. So these are the destinations and these are the sources of production. Okay, so the total capacity of Ahmedabad is 100. The capacity at the Indore plant is 300 and capacity of Hyderabad plant is 300. Production of the 100 products, 300 products and 300 products in the specific time period. Okay, so you can say this is your supply and the demand at Mumbai is 300, Kolkata is 200 and Delhi is 200. The total is 700. I'm writing the cost here. The cost of transportation for the per product. 543, 843, 975. Now, the name of this method is lowest cost method. So you're starting with the lowest cost from the matrix. So I've already told you where we do the allocation. We do the allocation in these cells, right? So, sorry. I'm again writing 3 here. So we'll do the allocation here. So ignore this. Okay. So minimum cost. Where is the minimum cost? The minimum cost is 3. So you can start with this cell or this cell, any of the cell. Let's start with this cell. Okay, so do the allocation here. How to do the allocation? Allocate the minimum of these two numbers, 200, 100. So yes. So now we have already used this supply from Ahmedabad 100. So now no more transportation from Ahmedabad. Now there is no products available for the transportation from Ahmedabad. So you are deleting this. Okay. So now you have already allocated 100 here. So you have to write 100 here. So now the next minimum cost is 3 again. So here, how you do the allocation? Minimum of 300 and 100. So the minimum is 100. So you're allocating 100. Okay, so now 0. So the demand for Delhi is fulfilled, demand of 200. So you are deleting this. So you have already allocated 100. So you're subtracting 100. So here the amount, the 200 products are available from Indore. So Indore can shift now only 200 products because already we have allocated 100 products here for Delhi. So the next minimum cost, what is the next minimum cost? Now we have already deleted this cells, right? So you are not allocating or not considering they are there. So you're not considering they are there. The cells which you have deleted or you have made a cross sign. Okay. So the next minimum cost is 4. So here you will allocate 200. Okay. So 200 to 200. So you can allocate 200. So here it is 0. So now this requirement is fulfilled for Kolkata. So you are deleting this. So from Indore, there is no more products for shipping. So you are deleting this. Now the remaining is 9 and you will allocate 300 to this Hyderabad to Mumbai. So you can find out the cost now where we have done the allocations A to D, right? A to D, Ahmedabad to Delhi, 3 into 100. Then Indore to Kolkata, 4 into 200. Then Indore to Delhi, our allocation is 100 into 3 or 3 into 100. The next allocation is from Hyderabad to Mumbai. And it is 9 into 300. So you can do the total, you can find out the cost of the transportation. So the total cost of the transportation is 4,100. So I think you are clear with the lowest cost method and northwest cost method. I'm not going in detail and not explaining you how to do the calculations for the stepping stone method or the Moti method. You can go to the Swayam, you can check your recorded video on the Swayam, and in that video, how to do the calculations for stepping stone method has been explained. The optimization methods are not completely explained in your book too. So, but in the recorded session, you can find out how to do the calculation. So I think you're clear with this, how to do the calculations or how to find out the solution when you using northwest cost method and lowest cost method. So I'm sharing a link with you. Kindly go to the link and share your feedback. And I'm explaining you, and I'm starting with you basically one more unit, that is assignment problem. So my plan is I will finish this unit today, the assignment, that is the unit number 10. So go to the link, share your feedback. If you have any query here, you can ask me. Otherwise, I'm starting with the next unit, assignment. Somebody have a question. Just like going to start the new organization. Just like going to start the new organization, but I want past year data, past year budget. But how I can fix the budget? I'm going to start the new organization this year. How can I give Just confirm that the slides are moving. Can you see the slides? Are the slides moving? Okay, thank you. So we'll start with the unit 10, that is assignment. So this is also the one of the optimization technique we use. And this is a special case of the transportation problem when your supply and demand is one for means you are allocating like in transportation. What we are doing is we have the sources and we have the destinations. The sources are means producing n number of units, and there is n number of units requirement at the different destinations, right? So here you can say this is a special case where you are doing one-to-one assignment. Like if you see the problem of the assignment, if you see the problem of the assignment, it looks like this. Okay, so let me show you. So it looks like this. So what it is, the task PQRS are given and you have to assign the task to the men 1, 2, 3. Okay. So here generally we need before starting we need equal number of rows. Number of rows must match with the number of the columns. Okay, so in this problem we have to do the adjustment. We have to add the dummy column here to make number of rows equal to the number of columns. So generally what you are doing, you are assigning one by one, means one task you are assigning to one man here. Okay, so this is assignment problem. So transportation problem, you are interested in knowing the cost of the transportation. So here assignments means you are assigning the task. Okay, so here one person can do just one task, and one task just required one person to for the completion, and one person can do just one task. So this is one-to-one assignment you're doing. Okay, so you are not assigning a single task by splitting into the two people or two men are not working on the same task, you can say, or one man is not working in the multiple tasks. So you are doing one-to-one assignment basically. So this problem is assignment problem. Okay, so you are doing one-to-one assignment. So you don't have that demand, supply, ending row and total with you here, because you're doing one-to-one assignment. So this is also one of the special case of the transportation problem, you can say. So let's see first the difference between transportation and assignment problem. So transportation problem contains specific demand and requirement in column and rows. Like you have the demand, you know the supply, available supply. So that is the transportation problem. In assignment problem, the demand and availability in each column and row is one. So you're assigning one by one, means one task assigning to the one person. Okay, so the total demand must equal to the total availability. So what you are checking, you are saying when your demand is not matching with the supply or the availability, you are saying your transportation problem is unbalanced. So you have to balance it, and then only you can proceed further for the further calculations. You're doing the same calculations, but you have to balance your transportation problem. So in what is the requirement of the assignment problem? Assignment problem, you are assigning one to one, right? So the number of tasks, if you're assigning to number of main, so they must be equal. The number of tasks must match with the number of main. Then only you can do the one to one assignment, right? So you check for the square matrix, means your number of rows must be equal to the number of columns. The number of rows must be equal to the number of columns. Okay. So the optimum solution involves the following conditions. Means if you go for the checking of the optimum solution, like I just explain you which methods we are using for finding out the optimum solution in transportation, and those methods are stepping stone method or Modi method. So when you come to the end at when your allocation is to m plus n minus 1, if you have n rows and m columns there, that time m plus n, let's say 3 rows 4 columns, so you need total allocation at 4 3 plus 4 minus 1, that is 6 places. Okay, so then only you can say your solution is optimum. So here, when you check, the optimum solution involves one assignment in each row and each column. So in each row and each column, we once we solve the example, that time you will come to know what assignment is in this particular assignment problem. Okay, so but you will find out the optimum solution involves one assignment in each row and each column. So you're looking for just one assignment in each row and each column, then you can say your problem is optimum. So in transportation, there is no restriction in number of allocations in any row or column. So as in transportation problem, we're saying that we are allocating at 2 places in the single row, or 2 columns. In the same column, you are allocating at 2 cells, right? So, but this is not the case in assignment problem. So in assignment problem, you are only one allotment to each row and each column. You can do only one allotment to each row and each column. Because why this is the difference? Because what we have seen when in the previous unit, like in transportation, from, let's say, from Indore, you can transport to Mumbai or to Kolkata at multiple places. You can do the transport from one place like Indore, which is the source or the production place. You can transport from that place to 2 destinations. But this is not the case here in assignment problem. You are doing one-to-one assignment. So you cannot do the allocation at 2 cells in single row or single column. Okay. So transportation problem is allocating multiple resources to multiple markets, and this is the problem of the allocation of resources to the jobs. So I think you are clear with the transportation and assignment difference at least. So this is our transportation matrix. So assignment problem is special case of transportation problem. The objective of this problem is to assign the number of resources to equal number of activities. So you have the resources, you have the activities, and you are doing one-to-one allocation, so as to minimum cost and maximum total profit of allocation can be obtained. Okay, so the problem of assignment arises because available resources such as main, machines, etc. having varying degree of efficiency. So if person A, if there are three people or 3 persons, A, B, C, and they are doing 3 works, like work 1, work 2, 1, 3. You are doing the 1 by 1 assignment here. Okay, so if your problem is like These are the random numbers I'm taking. So let's say these are the timings take by the or okay, so you have person one, person two, and person three, and you have three tasks like task A, task B, and task C. So you are doing the assignment one by one. So you are assigning one task to single person. So why this problem arises? Because for completion of the task A, the person one is taking, let's say, 9 hours, the person 2 is taking 8 hours, and person 3 is taking 10 hours. Also you have the three persons available, and person 1 is taking 13 hours for the completion of task B. Let's say the person 2 is taking 12 hours to completion of the task B, and person 3 is taking 11 hours for the completion of task B. So if you see, they have different efficiency to perform the different activities, and that's why the cost involved is different. So you are interested in maximizing, you can say, the total profit by allocating the work or minimizing the total cost you're spending on that particular completion of that work. Okay. So suppose that we have n jobs to perform on m machines, and our objectives to assign the jobs to machines at a minimum cost or maximum profit under the assumption that each machine can perform each job but with varying degree of efficiency. Though degree of efficiency is different for machine also, if the people are working on that or workers are working with that machine, so workers have different efficiency. That's why you have to do the allocation so that you can minimize the cost of the production as well as the maximize the profit from that. So this is the assignment problem can start that the form of M by N matrix, and CIJ is the cost matrix. So you can have the cost matrix or effectiveness matrix, where CIJ is the cost of assigning ith machine to the zth job. So you have different machines and different jobs, and you're assigning different machines to different jobs. Consider an assignment problem of assigning n jobs to m machines. Let Cij be the unit cost we have already seen. So Cij is the cost of the assigning the ith machine to the zth job. So let's say when your xij is 1, means you're saying your job is assigned to that particular ith machine, and when your xij value is 0, that you are saying your z job is not assigned to the ith machine. Okay, so once we solve the example, at the end you will come to know what actually it is. So you're maximizing the profit, minimizing the cost, subject to constraint. So here this is minimizing function because the Cij is the cost, so you want to minimize the cost. Subject to constraint, you're assigning that particular job I to Z, and if you're assigning it, you're saying it 1, and if you're not assigning it, you're saying it 0. So we solve this using the Hungarian method. So we have the one method, and this method for solving the assignment problem is Hungarian method. Okay, so remember this, we always solve the assignment problem using the Hungarian method. So we'll see how to do how to solve the problems using the Hungarian method. So I have explained here the way of solving the problem using the Hungarian method. I directly start the solving and then one by one we'll read this so that you will come to know what it is. Because if I directly start reading, you will become more confused. So let's say this is our problem. Solve the following assignment problem. So before starting with the problem, you need to check whether your number of tasks are equal to the number of workers available or not. So number of rows must match with the number of columns. So here there are 4 rows and 3 columns. So we have to add one dummy column, right? So let's add one dummy column. I'm adding the dummy column here directly. So let's say we have the worker 4. Okay, so now you have 1, 2, 3, and 4 rows and 4 columns. 1, 2, 3, 4. So now this is your new problem after adding the dummy column. Because before starting, you need to check whether your number of rows are equal to the number of columns or not. Okay, so if they are not equal, you need to add dummy row or dummy column as per the requirement. So let's go and read the step 1. First, check whether the number of rows is equal to the number of column. If it is so, the assignment problem is sent to be balanced. So in our case, the assignment problem was not balanced. So what we have done, we have added dummy column. So let's read the step 1. Subtract the smallest cost element of each row from all the elements in the row of the given cost matrix. So now this is your cost matrix. Whatever given problem is your cost matrix. Okay. So what you're doing, you're finding out the minimum of each of row and you're subtracting minimum of the row from each of the number. So let's go to the problem. So in first row, like what is your first row? This is your first row, right? So what is your first row? This is your first row, right? 9, 26, 15, 0. So what is the Z in the minimum of this? Minimum of this is 0. Okay, so you are subtracting 0 from each of the numbers. So your row will remain the same. In this case, the row will remain the same. If you have some another number here, you are subtracting that number and then only you find some of the changes in this given matrix. Okay, so in this case, in this problem, you're subtracting 0 from each of the numbers, so your first row remains the same. The same case with the second row, same case with the third row, same case with the fourth row. So what is the step 2 now? Subtract the smallest cost element of each column from all the elements in the column of the resulting cost matrix obtained by the step 1. So after subtracting what we have done here, first we have calculated the row minimum, then we have subtracted the row minimum from each of the observations. So now we have the transformed matrix with us. So now from that transformed matrix, we are finding out the column minimum. So what is the column minimum here? So here the column minimum is, for the first column, the column minimum is 9, right? So column minimum. So what is the column minimum? 9 here. The column minimum is 20. So there is no need to write the column minimum, but I'm writing this for your understanding. The column minimum is 6 and here the 0. So what you're doing is you are transforming your matrix by subtracting your column minimum from each of the number in that particular column. So 9 minus 9 is 0. 13 minus 9 is 4. Right? 35 minus 9. So your answer is 26. 18 minus 9 is 9. So what is the second one? Now 20 you have. So you are subtracting 20 from each of the number. That 26 minus 20 is 6. 27 minus 20 is 7. 20 minus 20 is 0. 30 minus 20 is 10. So the third column. 15 minus 6 is 9. 6 minus 6 is 0. Here again you have 9. 20 minus 6 is 14. And here you have 0, 0, 0, 0. So we have new matrix here, right? So we have to check whether our in each of the row and each of the column at least 1 0 is there or not. Check. In first column, 2 zeros, second column, 2 zeros, first row, 2 zeros, second row, 2 zeros, third row, 2 zeros, fourth row, 2 zeros. Column, check the column. First column you have 1 0, second column 1 0, third column 1 0, fourth column have all zeros. So in each of the row and each of the column you must get at least 1 0. If you are not getting a 0 in one of the row or one of the column, that time you are finding the row minimum or column minimum accordingly, and you're subtracting it and finding out the new matrix. Okay, so that the similar case we'll see in the next example. So but here you observe that there is at least 1 0 in each row and each column. Okay, so let's go back and read the next step. So examine the number of rows successively until the row with exactly one unmarked zero is found. So the next step is you are going through or examining row by row, and you are finding a row in which there is exactly one unmarked zero is there. So once you are reached with that row, make a assignment to the single unmarked zero by encircling it or squaring it across all the zeros in the column. So you are checking row by row now. So let's go back to our problem. So what you're doing here, you're checking row by row. So what is your first row? This is your first row, right? 0, 6, 9, 0. Is this row has single zero? No, the row with two zeros. So let's move to the next row. The next row is 4700. Again, two zeros. This is also not the row with single zero. Move to the next row. 26090. Again, the row with two zeros. Okay. So let's go to the last row. 9, 10, 14, 0. So now this is the row with a single zero. So what you are doing, you are doing the assignment at that zero with the row with the single zero. So here you are doing the assignment, and you have checked row by row, right? So you are deleting the column. When you are checking row by row, you are deleting the column in this method. And when you are checking row column by column, you are deleting the row. So now we are done with the row thing, right? So we have checked all the rows. So the next is, after checking rows, we go back to the column. So let's check the first column. The first is the first column with the single zero. Yes, we have the first column with the single zero. So we do the assignment here. So once we do the assignment here, we have checked the row wise. So we are deleting the, we have checked the column wise. So we are deleting this row. Okay. So now once we delete, we are not considering those figures here. Okay. So now second column. So you are checking column wise. Okay, so you are checking column wise. In this column, what do you have 1 0? Yes, 0 is here. So we are checking column wise. So we delete the row. Okay, so we go further in the third column. So what it is, again 1 0. So we allocate it, and we are checking the column wise, right? So we delete the row. So now how many allocations you have done? 1, 2, 3, 4. 4 allocations. If your number of allocations are equal to the number of rows or number of columns, how many rows or number of columns you have here? 4, right? So you have done 4 allocations here.
Hello, ma'am.
Yes.
Yeah, what is the purpose of this? We are
We are doing the assignment. So we are assigning the task to the people. So we have seen that the people are machines. If like here the tasks are given P, Q, R, S, and we have the different workers here, 1, 2, 3, 4. Okay, so the different worker needs different time in completion that particular task on that machine. And let's say he is spending the person one year. What this is given, these are the cost given, right? So the worker one is using the P machine uh, for uh, for and when he uses the machine P for completion of the task, he is spending 9 rupees, or he can complete the task with the machine P by just spending of the 9 rupees. So the worker 2, if worker 2 is using the same machine and he is performing the task with the machine P, to completion of that particular task on the machine P, or the particular task that time he is spending 26, the cost is 26. Okay, so these are the task P, Q, R, S. So main one need, if he is completing the task P, he is spending by spending the just cost of 9 rupees, you can say. The main two is spending 26 rupees for the completion of the same task P. The main 3 is spending 15 rupees for the completion of task B. And we have the dummy 4 person who is doing the cost, completing the task without any cost. Okay. So the efficiency is different. So we have to assign the main to the task so that they can perform the task with the minimum cost. Clear with this? Yeah. So here we have done the allocation at 4 places, like 1, 2, 3, 4. Okay, so and the number of rows and number of columns. So number, if your allocations are equal to the number of rows or number of columns, means here you have done the allocation at 4 places. You have 4 rows and 4 columns. So you can go further and you can calculate the cost. So now this is P, this is Q, this is R, and this is S. The worker 1, worker 2, worker 3, and worker 4. So what you're doing, you're assigning the task P to the worker 1, P to the worker 1. Okay. So you're assigning the task Q to the worker 3. Task R you're assigning to the worker 2. And the task S you're assigning to the worker 4. So P has assigned task 1. So P, so this figure means he can complete the task with just 9 rupees, you can say here for convenience. Then Q task is 3. Third worker is completing the Q task with 6 rupees. So task R is getting completed by the worker 2, 20 rupees, and you're assigning the task 4 to the worker, task S to the 4th worker. Okay. So that is 0. With he can do it with the 0 cost. So the total cost is 35. So this is the way we can do the assignments of the task to the workforce, and when the cost is given. So these are the cost given. Just remember that these are the cost given. So if the worker 1 completes the task Q, he is spending 13 rupees for the completion of task Q. He is spending 35 for the completion of task R. But the worker 2 is just completing the task R in 20. The cost is 20. Because different people are you can say they are they have some special task, and they are good in doing that particular work, you can say. So that's why we have to do this, and we have to assign the task to the workforce accordingly, so that we can minimize our cost. And this is the assignment problem. Okay, so which method we use here? The Hungarian method. Don't forget this method. The Hungarian method we use for the finding out the solution to the assignment problem. So this is one more example we complete this example, and then we'll stop. So let's read the example. You work as a manager for a chip manufacturer. You work as a manager for chip manufacturer, and you currently have 3 people on the road meeting clients. Your salespeople are in Jaipur, Pune, and Bangalore. So these are the places where the actually their salespeople are available. Okay. So they are at Jaipur, Pune, and Bangalore. Okay. We want them to fly to 3 cities: Delhi, Kerala, Delhi, Mumbai, and Kerala, or Delhi, Kerala, and Mumbai. So this is the city from. So you are basically, you have 3 people. One is at Jaipur, Pune, and Bangalore, and you are assigning them to their destination one by one. So the single person from a salesperson, let's say if he is in Jaipur, he either can go to Delhi or Kerala or Mumbai. So he cannot go to the 2 places at a time. So this is the problem of the assignment. So you're assigning the salesperson to the destinations. Okay, so the costs are given here. The table below shows the cost of airline tickets in NRI between the cities. So the cost is given, so you have to assign them such that the cost of the transport is minimum, right? So where would you send each of your cell people in order to minimize the fare? So clearly this is a problem of the transportation. So what we have to do, how to solve the problem? Hungarian method, right? So first step in the Hungarian method to find out the row minimum and subtract the row minimum from each of the amount. So let me write here the matrix again. Let's go to the next page and write it here so that it will be easy for us. So I'm writing the matrix here. So this problem is, yeah, we have Delhi, Kerala, Mumbai. So Delhi, Kerala, and Mumbai. And the self people are at Jaipur, Pune, and Bangalore. Okay, so the fare is 2,500, 4,000, and 3,500. 4,000, 6,000, and 3,500. 2,000, 4,000, 2,500. Okay, so you're doing the allocation. So first thing is you will find out the row minimum and the column minimum then. So first thing is find out the row minimum. So there is no need to write the row minimum, but I'm writing here for your understanding. So what is the row minimum here? 2,500. Okay, so here the row minimum is 3,500. Here the row minimum is 200. So what your next matrix will be actually, so you're subtracting your row minimum from each of your number in that row. So 2,500 minus 2,500 is 0. So here you have 1,500. So then 1,000. Okay. So now 3,500 is minimum for this row. So 4,000 minus 3,500 is 500. 6,000 minus 3,500 is 2,500. Then here 0. Okay, so the next is 2,000 is the minimum. So you're subtracting 2,000 from each of the number. So you have 2,000 here, here you have 500. So the next is you are finding out the column minimum. So here there is no need to find out the column minimum as it is 0, right? Column minimum. So what here it is 0. So for it here the column minimum is 1500. Here the column minimum is 0. So again, what you're doing, you are subtracting the column minimum from each of the amount in the column. So 0, 500, 0 will remain the same. So 0, then 1000 and 500 you will have here. So here you will have 1000, 0 and 500. So once you are done with this, the next step is check row by row, right? In the first row, we have 2 zeros, so we cannot consider this row. Second row is with the single zero. So you are checking the row wise, so you are deleting the column, okay? So the third row, so you are checking the row wise. So in the third row, only single zero is there, right? So you are checking the row wise, you are allocating 0 here. So you are deleting this. So now you remain with, now the next step is go column wise. So you have just one column. So you allocate it here and you delete the row. So now check number of allocations. So three allocations are matching with the 3 rows and 3 columns, right? So either 3 rows, you match it with the 3 rows or 3 columns. So 3 allocations. So you can go for the calculation of the cost. So how to do the calculation for the cost? So optimum cost you have to find, right? At optimum cost, how to find out what are your allocations you are sending from Jaipur to Kolkata, right? So you're sending from Jaipur to Kolkata. So the cost is 4,000, right? So what this is your allocation. So you can compare it here. So what your allocation is actually here, here, and here. So Jaipur to, you will send a salesperson from Jaipur to Kolkata, from Pune to Mumbai, 3500, and from Bangalore to Delhi by spending 2,000. So if you do the total is 9,500. The cost of the transportation for the company is 9,500. So we are done with the assignment unit here. Just remember that the method we use, the Hungarian method for solving the assignment problem. And this is the special case of the transportation problem where you're one by one you're assigning. Means you're doing one by one assignment. You can assign just one here. If you have the salesperson, so you are assigning per salesperson to the per destination. You're doing one by one assignment. After 5 years, so I'm sharing a link with you. Kindly go to the link and share your feedback. We are done with the unit 10 now. And in the next session again, I'm planning to take the 2 units so that we can finish the whole 14 units in 3 or 4 sessions in the next month. Thank you for joining. So see you in the next session. If you have any query related to the subject, you can just mail me. My email ID I'm writing here. I generally reply within a 1 working day. Okay. So thank you for joining. If you, yes, you can unmute yourself.
Yeah, ma'am. These two units, what you explained, no, PPTs are not same. Can you make sure that upload this? PPTs are not same, ma'am. These two
Okay.
units
Yes, yes.
in Swayam. Yeah,
Yes, yes.
please make sure to upload there. Yeah.
Yes.
Thank you.
Thank you. Thank you for joining.